This is part 2 of the Ionic bonding lab. In part 1, we made these cards and we used um, the Bohr model. We used the Bohr model to determine the electron dot formula and the ion for each of these atoms. We found that some of them, like lithium, beryllium, sodium, and magnesium, were called cations because they have positive ions, while others, fluorine, oxygen, chlorine, and sulfur, are called anions because they form negative ions. In part 2, we're going to form ionic compounds by placing one cation picture next to one anion picture. We'll determine what kind of ionic compound they form when the two elements bond together. Let's start with lithium. Find your table with the cation, anion, and ionic compound columns. And we're going to add lithium into the cation column because it's the positively charged ion. And let's look at it with fluorine. If lithium and fluorine combine together to make an ionic compound, what will they make? We'll write fluorine into the anion spot, but we're not going to call it fluorine anymore. Now we're going to call it fluoride. The INE ending here becomes IDE, fluoride. And this happens for all of the anions. They change their names. So now let's see what happens when they combine. Lithium has a positive 1 charge. Fluoride has a negative 1 charge. They cancel each other out, and so when they combine 1 to 1, they'll make a neutral ionic compound, and we're going to call it lithium fluoride. Just put the two names together, lithium fluoride. The chemical formula is a way to show what elements are found in lithium fluoride, and it also shows the ratio. LiF tells us for every 1 lithium, there's 1 fluoride ion in lithium fluoride. Let's do another one. I'll do 2 more, and then the rest you can do on your own. So we have lithium, the cation, and our anion for this one will be oxygen. Remember, we changed the ending to oxide. In this one, the whole part YGEN gets taken away and replaced with IDE. Now, when they combine, lithium has a positive 1 charge, but oxide, let's see, oxide has a negative 2 charge because it's going to gain extra electrons here and here. Do these match up? They don't. So if I do 1 to 1 lithium and oxide, I'm not going to have a neutral compound. So we have to add another lithium. And now with 2 lithiums, I have a total of positive 2 charge, negative 2 charge. They cancel to 0, which will give us our neutral compound. How do I show that in the formula, though? I need to show that there are 2 lithiums. So I have lithium oxide is the name, but I use a subscript 2 behind the lithium to say there are going to be twice as many lithium as oxygen. 2 lithium for every 1 oxygen. Li2O. We'll do another one like that now. so that you can see how it works again. Now we're going to add sulfur to lithium. Lithium goes in the cation spot on your chart, and then sulfur becomes sulfide. Sulfide. And let's see what happens when we combine them. Lithium is a positive 1 ion, and sulfur has a negative 2 ion. It wants to gain 2 more electrons, which will make it extra negative or negative 2. So I'm going to demonstrate it this way, and you can see they don't match up. They won't cancel out to 0. So I need to add another lithium. That way I'll have a total of positive 2 charge and a negative 2. I'll need a 2 for the lithium and a 1 for the sulfide. And there it is, lithium sulfide, Li2S. We don't draw the 1. It's understood 1 if there's no number. Lithium sulfide, Li2S. Now, you're going to try the rest of these. You'll do another lithium, and I think chloride is our last one to combine it with. And then you'll go ahead and do the other 3 cations the same way. Fill in your chart, and then come back to to the folder to find the answer key tomorrow. Good luck. Have fun.